Hello everyone, good morning. Today I'm talking about micro-frontends, and this is a migration story on the edge. This is the story of DAZN and how we migrated our front-end application into micro-frontends. Before jumping into the story, introduction first. My name is Max. I'm a principal engineer at DAZN. I grew up and was born in Rome, in Italy. Then I moved to London almost 5 years ago. You can find me on Twitter at _MaxGallo or at maxgallo.io. What is the agenda for today? So our journey is divided into 4 steps. We will start with the context, so what we need to understand in order to move forward to all the other parts. And then we're going to see which is the problem. And from the problem, we will tackle the problem with a solution that we will finally analyze at the end of our journey. So context, problem, solution, and analysis. Let's start with the context. Context is crucial. Context is fundamental. How many times have you thought about why that person or that team took that decision? That was so stupid. I would have never done something like them. And the truth is that the only thing that they had, which is different from you, was probably a different context. So context is what gave us the opportunity on deciding which is the decision that you are going to make for a specific problems. In the architecture space, there are also architecture decision records which help tracking down the context when a decision was made. So context is important, and we will start from learning which is the context of DAZN. DAZN is a live sports streaming service. And in the live sports world, you have to imagine that there are a lot of people around in the platform watching some VOD content, or maybe the NBA finals that were live at 3 a.m. that you didn't want to see live, that you're watching the day after. But all the non-live content for the DAZN pretty much resemble the low-end spectrum of this graph. Then suddenly is 10:30 p.m. and there is El Clásico, there is Barcelona versus Real Madrid, and boom, we've got a huge user spike that is putting a lot of pressure under our systems. So for the nature of our solution, having something that scale is fundamental, and that has to be taken obviously in the front end, in the backend world, but also in the front end. So scalability and user spikes are one of the contexts in which we will work today. Second is company growth. When I joined DAZN in 2017, the engineering department was quite small, less than 10 people. We are now between 200 and 300 between engineers composing in general the engineering department. And that led us to a growth not only in one location, but actually in 4 locations around Europe. And the way these changes a company is quite radical, because you have to imagine that all the dynamics and all the communication are way different when you are 10 developers or 200, 300. To give you an example, with the AWS account, when I joined in 2017, we had one AWS account, and at some point we weren't remembering who the credit card connected to that account was. So we were super worried for 2 or 3 days because it was expiring, and we didn't know who the credit card was, who the credit card belonged to. Nowadays, we have an entire team dedicated to provide at least 4 different accounts to each team working on the front end, on the back end. They're all managed. There is a CLI that helps you how to logging in, logging out, managing permissions. So that's the kind of difference that we are facing, that we faced in the past few years. And one thing we push for a lot is autonomy. Autonomy is what gives a team the possibility to go to production independently and in the most efficient way possible without having to talk and discuss with other teams. Then we have live events. I grew up in Rome, in Italy, and one of the common thing that I remember from when I was a child was that even if I wasn't watching a specific football match, out there was someone else watching it, and my neighbors were streaming and celebrating and booing for all the penalties, the goals. So I was practically able to guess the results of a specific match just by hearing it. In London, that's not exactly the case, but nowadays you get notifications on your mobile phones, you get all sorts of updates from your friends. So when we are dealing with live events, we cannot really provide you a goal 5 minutes after. That's not acceptable from a customer point of view. So speed is crucial in when we deliver. And of course, not everything is about minutes, sometimes it's about seconds, but speed is crucial and is very important for DAZN. Then we have two front-end applications. Why two? So on the left-hand side, we have DAZN 1.0. This is an application which has been built by a third-party company at the beginning of DAZN and which was used to serve millions of customers, that is currently live, that if you are a DAZN user, you probably have used it. And this is what the company was using for the final users in all these years. At the same time, we have DAZN 2.0 on the right-hand side, which is the newer application which has been developed internally by the DAZN engineering department that is aiming to replace 1.0. So 2.0, new architecture, new thing replacing 1.0. But for the context, I want to leave you with the idea that it was a third party, one company working on the existing project that was live, and the DAZN, the engineering department internally, which was working on the newer version, on 2.0. And that is the context. So context for DAZN, for a live sports streaming company, are user spikes first, then company growth, huge company growth, live events, remembering the neighbors streaming goal, and also two front-end applications. So this is the context in which we're gonna move forward. And we are moving forward with the problem. So what is the problem exactly? The problem is that we have two front-end applications which are functionally equal. So all the functions, the functionalities available in 1.0 in this application here are reflected in 2.0. So the new application is not adding anything new yet. What is new is the architecture behind it. So DAZN 1.0 is a monolith which contains all the functionalities. DAZN 2.0 is made of micro-frontends. These micro-frontends are representation of a specific domain of the whole application. So the whole application has been split in these vertical micro-frontends, which represent a specific domain, such as, for example, the sign-in and sign-up pages, so the whole authentication experience, that's one micro-frontend. Then we've got the help pages, all those pages for help out customers, the live chat. This is another micro-frontend. Then we've got the catalog, which is, for example, where you see all the events and where you can play them. Then we have my accounts. But you can see how all these subdomains of the whole monolith application are now split in micro-frontends. They are independent, and there is only one of these micro-frontend in the page per time. The good news is that by doing this, we allowed individual team to work on micro-frontends individually. And one of the first benefits that this brought was the fact that allowed us to deploy these micro-frontends independently. This is the probably holy trinity of AWS, which is our cloud provider that we use to provide a front-end application to our customers. And in AWS, our architecture is relatively easy, and it uses Route 53 for the DNS, CloudFront as a CDN, and then we store our micro-frontends on S3. The fact that we are now using micro-frontends allow us to deploy individually the different pieces. So if I'm a team working on the help pages and the live chat, and I've got a bug fix, I don't have to talk with everyone else in the company or everyone else in the front-end world to deploy my fix. I'm in charge for that. I can deploy that. I can roll back. And you can start seeing the autonomy context, how important was in this transition time. But what do I mean about transition? While doing this transition from Monolith to micro-frontend, we have a few challenges. One of the first one was, how do we migrate safely our users from a Monolith application that had everything to something that was represented in a different way? So the same functionalities, but split in different parts. So that's a well-established concept in the backend world, in the microservices worlds, and that's called the Strangler pattern. This pattern helps understanding, helps defining some rules for how to migrate from a monolith to microservices, and we applied the same concept to the front end. The Strangler pattern says that there is a piece in the middle between users and the monolith, which is called proxy. Could be called differently, but the scope of this part of the architecture is the same. And this is in charge of deciding which of the requests to the monolith should instead be redirected to the new microservices, and in this case, to micro-frontends. So if we reason in the context of micro-frontends, let's think about help pages once again. In the moment that the team working on help pages is happy with their micro-frontends, they deploy that in production and it's available here. The only thing that we have to do in the proxy, it's saying every time a user type a URL that looks like a landing page, redirect that user to 2.0. And that's what the proxy does, and that's what at the core at the Strangler pattern. And this pattern aims to remove piece by piece all the functionality of the monolith to leave it at some point completely empty of any routes. So all the connections will now go through the micro-frontends. And that's the first challenge. The second challenge is we still want to avoid big bang releases. If you think about the authentication micro-frontend, the one that is in charge of sign in, sign up users, that's crucial. And we cannot really deploy that worldwide, even if it's a small part of the entire front-end application. So that's again something that we borrowed from the backend world, and this is the concept of canary releases. Canary releases is a well-established concept that says that helps you redirecting part of the traffic from one specific application to another one. In our context, we are routing with a router, this time in between. Let's say 90% of the traffic still on the monolith and 10% of the traffic on the micro-frontends. This granularity allows us to minimize the impact that we have on our final users. So we release to a small percentage, we see our metrics, we set up the alerts, the dashboard. If everything looks green, we increase that percentage. And we keep repeating that until we are live. So with these two methods, we saw that in reality, we are always splitting the traffic in one way or another one. In this case, we are splitting between micro-frontends and monolith, and this is our architecture. So somewhere in between here, we need to be able to do that because this is our problem. This is our challenge. We don't know the solution yet, but we know for sure which are the requirements for this solution. And these are important because later on, we will come back to the requirement to check if we have a solution that fulfills all those requirements. The first requirement is auto-scaling. We already have a huge amount of things to consider when we deal with backend and APIs regarding auto-scaling. And this is not something that we want to do in the front end as well, if possible. So if our solution was dealing with the whole scaling situation by itself, that could be perfect for us. Then we've got fast. Our solution has to be fast. We cannot add 2 or 3 seconds of delay to every request because we want to split the traffic. That's hardly going to be something that you are able to justify. And then we want it to be front-end independent. Why front-end independent? Let's go back for a second to the context. This application is being developed internally by the zone engineers with multiple teams, each of which is responsible for a different micro-frontends. And this is a monolith application developed by a third-party company. So in this situation, you always have some communication overheads in the moment you have to communicate between the two companies. As much as you are collaborative, there is always a lot of going back and forth. So ideally, having a solution which is completely front-end independent, that doesn't even know if this is React, Vue, or if this is something else, that would be our preferred choice. And then we would like to keep the same URL because all of this has to be transparent. One of our key metrics was that if not a single user realized what was going on, that was a successful migration. So keeping the same users is a strong requirement for us. And then we want to follow the best practices from the Strangler pattern and canary deployment because we saw how those can be helpful. Let's move to the solution. What is the solution? I want to introduce you to Lambda Edge. Lambda Edge are a service from AWS, which are a special case of AWS Lambda, which you may be already familiar with. AWS Lambda are a service that allows you to run a specific function without managing any infrastructure. So you only deploy your code and AWS takes care about how to scale that, where it runs, when it runs, and also takes care of any amount of request that you are hitting that function with. So it's going to auto scale. And also it allows you to pay only per number of functions that you use. So what is the difference exactly between a normal Lambda and a Lambda at the edge? The difference is where these Lambdas are running. The Lambda at the edge are running on the edge, so on CloudFront, on the CDN, on the content delivery network. That means that we have multiple instances of all these Lambdas across the globe, and they are actively running in the CloudFront, in the content delivery network, in the CDN. What does that mean exactly? The CDN is where we cache items. How can a Lambda, a function run where we cache the items? This is the flow of a request and a response that we're going to see starting from the left-hand side. So this is the request. The first thing that we hit is the first Lambda at edge type that you can set up, which is the viewer request. And this is the cache layer. So this is where the items are cached. So in case the cache is not valid or it's stale, the request will go through and will hit another type of Lambda at the edge, the origin request. Then it will go to the origin, fetch whatever thing is happening, the origin providing. And then it became a response. So it will fire a Lambda at the edge origin response and then a viewer response before returning as a response. So all of this is happening in CloudFront, and this is the dotted line is where the items are cached. So of course, if the viewer request is hit, but after it, the item is found in the cache, we don't go here to the origin request, origin response, but we move straight away to viewer response here, and we go back to response in a much faster way. So in this scenario, we are seeing how Lambda at the edge can be set up as one of these 4 kinds. So when you create a Lambda at the edge, you actually have to specify, okay, this is a viewer request, this is an origin request, and so on and so forth. You can set up up to 4 Lambda Edge per CloudFront distribution, 1 for each type. But one of the key aspects of the Lambdas are that they have an input and an output, and they work with that input, transforming that into an output. Which are the inputs and the outputs of the Lambda at the edge? The inputs and the outputs are what we call CloudFront event, what AWS calls CloudFront events. They are a representation of a specific request in a JSON format. And you can see that here we have an input that is going to get a specific item from a specific origin, which is DAZN.s3.DAZN AWS. So this is a specific S3 bucket. Then we run our origin request, for example, and we transform that into something different. So this time we are not going to get it from the same S3 bucket, but this is going to a different S3 bucket. This is DAZN2. So we transformed the S3 origin bucket from DAZN.s3 to DAZN2.s3. That subtle difference start opening our minds into where this Lambda Edge can be used for. We can redirect traffic. We can say, instead of picking the items from here, you should pick it from there. And that's super powerful. Last thing I want to cover about Lambda Edge is some challenges that you have to face while dealing with them. So the first one is the concurrent limit. There is 1,000 concurrent execution per account per region. That's quite generous. You can ask AWS to increase that limit to 5,000 if you have good reason. And so do your own math. That's quite generous limit. I recommend it for vast majority of the cases. That's more than fine. Deployment time. This used to be one of the problems in the past, where it was taking up to half an hour sometimes. Nowadays, it's always less than 10 minutes. I like to think it in the 10 minutes range, because this is what I see from our pipelines. But 10 minutes is kind of the worst case scenario. So we are more around 5, 6, 7. So that's the time that it takes to deploy the function into all the edge locations. So again, we'll come back to it at the end, but think about that in case you have to very time constraint that you want to take into account. And then we got metrics and alarms and Lambda logs that are all spread across AWS region. So anytime you want to find a specific log from a Lambda, you need to know where the request originated from, and you will find a log in the closest region where those functions did run. So Lambda Edge is convenient. They run much closer to our final users, but the logs are scattered across 11 AWS regions. And that's true also for metrics and alarm. AWS did quite a nice job there, started to centralize a little bit more with dashboards, and with logs, there are suggestions on how to do logs aggregation with Kinesis and Firehose, but it's still something that you have to do it manually. It doesn't come for free. And that was the last bit for the solution. So we saw the context, we saw the problem, we saw a potential solution. Now let's face the reality. Is that solution good for us? I want to start with costs. We didn't mention cost in the at the beginning, but I feel that is an important thing that a lot of people wants to know in advance before committing to a specific technology, and you have to do that in advance. So this is our Lambda running in Frankfurt, and we have an average of 2 milliseconds, so it's quite fast. The number of requests in December, January, and February last year went from 300 million to 400 million, and the cost was between $500 and $750. That's calculated per number of requests and gigabyte per second. Overall, my suggestion is that they are cheap. Compared to other services, they are quite a cheap way of doing these kind of things. So I wouldn't be too much worried about cost. But then let's find out if that suits us well in the context of all the requirements that we had before. The first thing that we see from the diagram here is that it starts already with the right thing, because it fits quite nicely in our Holy Trinity frontend static setup, because Route 53 is already there, CloudFront was already there. The only thing that we did is add a specific functionality within CloudFront, but we didn't have to change anything. So autoscaling comes for free. We saw the Lambdas are entirely managed by AWS, so you don't have to worry about that. There are limits. Of course, if you're doing something very, very silly, you may hit those limits, or you have a huge amount of requests. But for normal use cases, even DAZN use cases, autoscaling for AWS Lambda functions at Edge is fine. Then we have fast. We saw the average 2 milliseconds. That's fast to me. And then front-end independent. This is completely different, and this could be developed even by another team if you want to. And you don't have to rely on the fact that this is written in React or in Vue or in Svelte or in other things. You just write the Lambda Edge in whatever language you prefer. In our case, we prefer JavaScript, so it's JavaScript everywhere. That was quite convenient. So you can see what's going on. If you're a front-end dev working on a specific micro front-end, you can see how the Lambda works. And that's always powerful to have this kind of transparency. And then same URL. Again, that's coming for free. www.dazn.com/home. Didn't change because this was already part of our architecture, so thumbs up. And then we got strangle pattern and canary deployment. We have a rough idea between events and outputs, inputs and outputs of the Lambda with CloudFront events that this is possible. But exactly how we're going to do this, let's see it now. So canary deployment and strangle pattern are both, or I want to consider both, as two different configuration from the same redirection logic. So at the core, in the Lambda Edge, there is the redirection logic that is capable of redirecting requests from one place to another one. This logic can be driven by either canary deployment approach, when you say, Italy is all good, let's go 100%. Germany, we still want to make sure that we are doing fine, let's keep it at 50. And on the right-hand side, we have the strangler pattern when we work more at domain level. So are all the sign in and sign up pages ready to go? Yes, let's enable that. Let's route the traffic there. Are the help pages ready? Yes. Is catalog ready? Not yet. Let's keep the redirection to 1.0 to the monolith up and running until the team responsible for that is ready. Again, autonomy and independence. So we're going to see how to work with the canary deployment, but the strangler pattern follows the very similar concept. My question right now is, where do I store the configuration? And we basically have two options. The first option is here on the left-hand side, is to fit the configuration, to put the configuration inside the Lambda itself. This means that if you want to change the configuration, you have to redeploy the Lambda. And nowadays it takes less than 10 minutes, so it's probably okay-ish. Back then, it used to take up to 30 minutes, so that was much more risky. Considering if you want to do a quick rollback during a live event, you cannot wait 30 minutes. And so we decided for a slightly different approach, which is to put the configuration externally from the Lambda. So the Lambda is deployed with the normal flows, and every time the Lambda have to decide how to route traffic, it will fetch the configuration. Where is the Lambda fetching the configuration from? And how can we keep the 2 milliseconds? Because that 2 milliseconds average that we saw before was comprehensive on all of this. So this is our architecture again, and we see now that from CloudFront, from this CloudFront and this Lambda at the edge, we are performing a request to static files to keep things easy, where we store information about the canary deployment, like Italy 100%, Germany, Canada, and so on and so forth. The first question is why there is another CloudFront in front of this S3. The answer is that CloudFront doesn't allow Lambda Edge to request to the same CloudFront to avoid any kind of loops. So this CloudFront is not allowed allow to perform any request on itself. So it has to be another one. But then the second question is, why a CloudFront? Why do we need a CDN in front of S3? This is just a static files. Can I just point to S3 directly? Yes, you can, but you have a problem, and you have to remember where these functions are running. These functions are running globally, and that means that they could run in Japan, they could run in Germany, they could run in Alaska, or they could run all around the globe. So as much as S3 is this magical thing when we can store everything, that's pretty much a physical server somewhere in the world. So you have to take into account that if you were using just S3, the round trip from here could be quite nice if you're going from Germany to Germany, but could be a nightmare if you're going from Japan to Germany. So putting another CloudFront, make sure that we are caching the items on the edge in CloudFront. So the request is going from CloudFront to CloudFront for the vast majority of the time. And with that trick, we are able to keep the average, for example, in Europe, to 2 milliseconds, which is quite good. Last thing, when you redirect traffic, that you should remember is always to bear in mind that the session has to be sticky. So whatever you present to your user as one of the choice for canary releases or following the stronger pattern, if the user turn off their computer and switch it on and access the DAZN.com the day after, you want to provide the same experience. So with an origin request Lambda and an origin response Lambda, we were capable of implementing the sticky session using cookies to prevent and to give actually user a consistent experience. What are the takeaways? So I want you to start with context every time you approach every problem, but especially in this case and when we are talking about architecture and solutions that may be useful for you. Vertical micro-frontends are a very nice and effective way to split a monolith and to individually assign teams to these micro-frontends, to being able to deploy each micro-frontend autonomously. So if your company is growing a lot, vertical micro-frontends are definitely here to help. And after you did that, you have to migrate from the monolith to micro-frontend, and working on the CDN is now possible. And we saw the example from AWS, but this is not only about AWS, this is also about Cloudflare workers. So there are different solutions that achieve similar things, but this is super powerful. And we cover routing and canary releases, but that is just the beginning. There is server-side rendering, search engine optimization, authentication, authorization, real-time. There is way, way more you can do on the edge. So we are not living anymore in a world when we deal with client-server relationship. Well, we have client, server, and CDN. So let's make use of that. Thank you very much. The slides are available at this URL, and thank you again for listening.